Here, side A equals 6, side B equals 8, side A equals 35 degrees. We know it's going to be law of sines because we have a known pair, and we know it's going to be the ambiguous case because only one angle was given. We get 6 over sine of 35 degrees is equal to 8 over sine of B. And we cross multiply. Six sine of B equals 8 sine of 35 degrees. Continuing to isolate our sine, we'll divide both sides by 6. Sine of B equals 8 sine of 35 divided by 6. You could simplify that fraction if you wanted, but I wouldn't since I'm just going to plug it in my calculator. And inverse sine to get our B. B is going to be sine inverse of this fraction here. And we're going to plug it into our calculator. When we do that, we get not an error, we get a number. Remember, we're rounding to the nearest hundredth. We get 49.89 degrees. And that's a great answer. But I don't know if this is going to swing one way or another to create one or two triangles. So I always assume that there are two triangles in existence. Now, we're going to use this fact 2 here, that sine of theta equals sine of 180 degrees minus theta, to get the second angle, the second possibility. All right, so we're going to do possibility 1 and possibility 2, and I'm going to use subscripts to distinguish between the two. So we're saying that angle B for possibility 1 is 49.89 degrees. Now, since you didn't get an error in your calculator, when you put this in, you know for sure you have at least one. It's just now determining whether we have a second one. All right, so in the possibility that we have a second one, our angle B would be the supplement of this because of that property 2 above. And when we subtract, we get that B2 would be 130.11 degrees. All right. Let's go on to finding our third angle A, because right here in this step for these two parts 1 and 2, this is where we're going to determine whether there's just one triangle or two triangles. Angle C, we know that the three sides of a triangle have to add up to be 180 degrees. To find our third angle, we're going to take 180, subtract A that was given, and then subtract B1 that we figured out. And again, you should always get an answer for this one. It's the second part that's a maybe. Oh, we're going to get 95.11 degrees. We're going to do the exact same thing with the second triangle. To get the third angle, we're going to take 180 degrees, subtract the angle A we were given, and then subtract the angle B that we found here in the second case. When I do that, if I get a positive number, then a second triangle exists. And here we get 14.89 degrees, so we are going to have this second triangle here. If angle A and angle B together are already more than 180 degrees, you're going to get a negative answer, and that's why we couldn't possibly have second triangle because there's no way that the sum of the interior angles can be more than 180 degrees. But since we got something that wasn't a negative, that tells us for sure two triangles. All right, last thing we need to do is find side C for both of these situations. To find our side C, we're going to use our known pair, 6 over sine of 35. And that's going to be equal to our side C1 over sine of 95.11 degrees. And we'll cross multiply to solve. 6 sine of 95.11 equals C1 times sine of 35. And then we'll divide and get that C1 is 6 times sine of 95.11 divided by sine of 35. We'll plug this into our calculator. Rounding to the nearest hundredth, C1 is 10.42, and our unit is yards. We need to do the exact same thing with our second case triangle. We'll start our proportion with our known pair, the one that was given, and then that's going to be equal to side C2 over sine of 14.89 degrees, cross multiplying. We get 6 sine of 14.89 degrees equals C2 times sine of 35 degrees, and then we'll divide. C2 equals 6 sine of 14.89 divided by sine of 35. Plug that into your calculator and round to the nearest hundredth. We get our second side C to be 2.69 yards. All right, one more application. I know the video is long, so if you need to take a pause and then come back to the application, then do that. All right, last one, application. After a windstorm, you notice that your 16-foot flagpole may be leaning, but you're not sure. From a point on the ground, 15 feet from the base of the flagpole, you find that the angle of elevation to the top is 48 degrees. Is the flagpole leaning? If so, find the acute angle to the nearest degree that the flagpole makes with the ground. All right, well, the first thing we need is a picture. Here's my ground. Let's assume it's like perfectly straight, which it is definitely not. Let's try again. All right, and then I have a flagpole that may be straight up and down, maybe leaning. I think when I draw it, I'm going to make it a little bit leaning. It's important to be patriotic. All right, so it tells me that you notice that your 16-foot flagpole, all right, so this is 16, from a point 15 feet from the base of the flagpole, so over here 15 feet, you find that the angle of elevation to the top is 48 degrees. And we want to know, is our flagpole leaning? Well, how would we know if it was leaning? If our angle right here that the flagpole is making with the ground is anything other than 90 degrees, then our flagpole is leaning. So if we can figure out what that is, we're in good shape. We can answer our question. All right, well, let's look at what we're given. Notice that we have this side 16 and the angle across from it, 48. Since I have a pair That tells me law of sines is appropriate. The other piece of information I was given is that this number here at the bottom, which you can't see because of my grass, this number here at the bottom was given, and with law of sines, things are paired up, so we could figure out what that angle would be. Now, why is that helpful in helping us determine whether it's leaning? For our angle at the bottom to be 90 degrees, it means that these other two, the yellow and the blue one, they have to add up to be 90 degrees to force that one to be 90 degrees. So if we figure out this and find it to be anything other than complementary to 48 degrees, we're leaning. All right, let's set up our law of sines. We'll call this angle theta up here. 16 over sine of 48 is equal to 15 over sine of theta. We'll cross multiply. And then we'll divide by 16. And to figure out theta, we'll need inverse sine. Theta is going to be sine inverse, so this fraction here. Plugging that into our calculator, and we'll round to the nearest hundredth. We get theta to be 44.16 degrees. Since this is the ambiguous case, it is possible that we have a second triangle, so we really do have to go through our second triangle test. To get our second triangle, or our second theta, theta 2 is going to be 180 degrees minus theta 1. So theta 2 is going to be 135.84 degrees. To get the third angle at the bottom, I don't know, call that alpha. This alpha 2, remember we find that by taking 180 minus the angle that we were given, which was 48, minus this theta 2. And if we get a negative number, then we know that a second triangle is not going to exist. So when we subtract these, we get this alpha 2 to be negative 3.84. So that means a second triangle is not going to exist, and the only one we need to worry about is this 44.16 degrees. All right, let's get back to answering the question in our application problem. So the question is this flagpole leaning? So to determine whether it's leaning, that means that our angle theta here has to be complementary with the 48 degrees, and it's not. When we add those two together, we get 92.16 degrees. So that means that we're leaning. And it asked, what's the question here? If so, find the acute angle to the nearest degree that the flagpole makes with the ground. Well, 92.16 is not acute. Remember that acute has to be less than 90 degrees. So to get that acute angle, we're going to subtract from 180 degrees. Right, really what we're finding is this angle. So let me put my grass back. really what we're finding is this angle right here. 180 degrees minus 92.16 degrees. Our flagpole is making an angle of 87.84 degrees, with the ground rounded to the nearest angle, 88 degrees.